Hi my friend. Today we will gather for presentation on very capacity. I will give you a presentation on very capacity of soil. First of all, I would like to give introduction about the geology or about the soil. The most widespread use of soil is work and is the substratum over which all the structures is to be built. All the loads of structures is based on the soil. So for that the soil has a very high strength to catching this all the loads of structures, and the load of structures is generally complex. Means the complex stresses are act on the structures. Then the history behind it a very large history that is the Walker has invented the soil calculation for very natural soil, but it has some deficiencies. Then the mankind are modified it. Then after that, Mr. Bell in 1950 also modified because the accuracy is applicable for only sandy soil. It is not applicable for poisonous soil. So Mr. Bell in 1950 he modified the Rankine theory. It is also we should calculate the bearing capacity of poison soil. Then after that, Mr. Frederick also modified the theory of Bell, and he added a bearing capacity of soil. So this is the ultimate bearing capacity, allowed bearing capacity, safe bearing capacity. The value of this was calculated by Mr. Travis equation. And in our presentation or in our geology chapter, we studied Travis assumption theory and its equation. So you know this is the award of this. People call him as the father of modern soil mechanics. His goal in Czechoslovakia. He taught at MIT 1925 to 1929, and after that he taught at Harvard in 1938. And after there are 6 methods of bearing capacity with determination. In that, I would like to give information about the assumptions of Taylor's theory. As you see, assumptions of Taylor is the soil is to be semi-inclined, homogeneous, and isotropic. The surface is to be horizontal, and the pressure acts is vertical, and symmetrical. The footing it should be rough, and the ground is to be surface of ground is to be horizontal. And, this is Taylor's theory diagram. As this is that is column footing, which is a ground level and subtraction level over which the footing is to be based on. The column is seen into the soil at a subtraction over which the footing is to be based, and it creates a zone, free zone, that is zone of no shear, zone of radiation, and zone of isolation. So in the I section there is a zone of no shear. In the second section there is zone of radiation, and there is third section zone of linear section. Bearing capacity and its importance. I think we all know about bearing capacity. Yes. Yes. So the definition of bearing capacity is defined as the maximum average intensity that the applied pressure on the loaded area is carried before it swells here. And bearing capacity is very important in our civil engineering department, because as we know the bearing capacity of soil, we construct the structures at a certain load. So the role of bearing capacity in our civil engineering is as foundation designing, consolidation and compression of earth and gravity dam, retaining walls and tunnels, etc. Then concepts of bearing capacity. So, as I said that the bearing capacity is very important in our structure. So it is main criteria in our foundation designing to calculate the bearing capacity of soil, and the stresses induced in the soil it should be very limited. The stresses are mainly shear stresses and bearing stresses. Also, the lateral movement of soil under the foundation and the shear failure is one cause of our failure. Then the excessive settlements or uneven settlements are to be important criteria in to see in our structure. Then Mr. Terzaghi calculated values of bearing capacity, that is ultimate bearing capacity, allowable bearing capacity, and safe bearing capacity. So ultimate bearing capacity means what? Ultimate bearing capacity is it is defined as it is that the maximum unit pressure in which the soil can the foundation can stand without going rupture or uneven settlement, excessive settlement of structure. Then allowable bearing pressure that is denoted by QA, and it is the maximum pressure the foundation soil is subjected to considering both shear failure and its settlement. Then safe bearing capacity, it is the maximum pressure. It is the maximum pressure in which the foundation can if it tolerate, but it does not tolerate or it stands. So this is the bearing capacity. So this is the three values calculated to the bearing capacity of soil. It's implemented by Mr. Terzaghi. And effect of water table on bearing capacity. Water table is very important factor to be considered in our when calculating the bearing capacity. I think you all know about water table. No? Water table means this is the water level over the ground. And as the rise of water in our substratum, I think we diagram that substratum and to the our ground level. When the water is increases, when it is increases in this level, means between the ground level and our substructure, that substratum, and when it is increases, in sandy soil or cohesion soil, there is a chances of rupture in the structure, and if if the water table is increases in the ground level and the breadth and the depth, when the depth is increase when means the depth is greater than its breadth, then its chances of 50% chances of rupture of the structure. Understand? So this is water table, and it is very important to calculate bearing capacity. Then for calculating bearing capacity of soil, there is a two methods that we see in our presentation, that is plate bearing test and the standard calculation test, that is called as MPT. Plate bearing test. So the plates are inside our ground, or it's fixed to the ground, and the pressure is applied on the column with the help of hydraulic jack, and the dial gauge is calculate the pressure. To calculate the pressure, when the hydraulic jack is then the pressure is applied with the help of hydraulic jack on the stack plate. We should calculate the pressure with the help of dial gauge, and we see the pressure which will be increased, and what are the surface should be horizontal. If it is not, then it should be horizontal. Then the pressure we should apply the hydraulic jack pressure. There is a settlement of a structure. So the settlement of a structure is to be 0.02 mm. So then by applying pressure hydraulic jack continuously, the settlement is once it should be in a 0.1 mm. It will I think should be constant. So this is a plate flow test, and next is our SPT, that is standard penetration test. In standard penetration, it is just like our bore cutter method as we practice that. in that the upper the speed spoon sampler is deep into the borehole, and for that the surface of the borehole it should be plain. It should be plain, and then the split spoon sampler is dig into that, and then the number of hammer blows are required to driven into 150 mm of sample sample is counted. Means the 150 blows are hammered into the split spoon sample. Then if the goes on 150 mm, also then after also the further driven is 150 mm. This continuously 150 mm oscillation are calculated in 3 steps. First 150 mm, next 150 mm, and next 150 mm. So we calculate the n numbers, means that is the standard deviation number in second 150 mm and third 150 mm. With the help of that we calculate the n number, and this is due for calculating bearing capacity of soil. Then earth pressure. Earth pressure have two types, that is active earth pressure and passive earth pressure. Active earth pressure is acts on a retaining wall, and active earth pressure is defined as the pressure exerted on a retaining wall to the slight movement of wall away from ceiling. Understand? Yes. And the passive earth pressure, it is the pressure acts on horizontally to the wall, or it generally compresses, it compresses the